You've now learned the theorems and postulates needed to prove angles congruent or supplementary when two parallel lines are cut by a transversal. Today we're really going to focus on the converses of those postulates and theorems. So first, how would you state the converse of the corresponding angle postulate? Remember that the corresponding angle postulate says that if two parallel lines are cut by a transversal, then corresponding angles are congruent. So think about that converse, write it down in your notebook. And you should have written, if two lines are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. Notice how now we're actually concluding that the lines are parallel based upon the relationship between the angles. So let's look at another one. How about the converse of the alternate interior angle theorem? Write that converse in your notebook. You should have written, if two lines are cut by a transversal so that alternate interior angles are congruent, then the lines are parallel. Okay, how about the converse of the consecutive interior angle theorem? You should have written, if two lines are cut by a transversal so that consecutive interior angles are supplementary, then the lines are parallel. And lastly, we have the alternate exterior angle theorem. Write the converse in your notebooks. You should have written, if two lines are cut by a transversal so that alternate exterior angles are congruent, then the lines are parallel. The one thing I want you to notice, if you're looking at all of those converse statements that you just have written, it's knowing that you have a certain angle relationship, whether it be corresponding angles congruent, or alternate interior angles congruent, alternate exterior angles congruent, consecutive interior angles are supplementary. We always had the conclusion that the lines were parallel. This leads us to find ways that we can prove that lines are parallel. There are 4 ways to prove lines parallel, and they are the converses of those theorems and postulates that we talked about when we were finding the angle relationships. So write these in your notebooks. These are the 4 ways to prove lines parallel. They are the converses of the postulates and theorems. And as you know, before we use any theorems or its converse, we would like to prove that it can work for every case. And once we prove these theorems and then the converses, we can then add them to our reasons bank. So we're not going to go through all 4 of the proofs, but I'm just going to show the example of one. You will be proving those other ones later on, whether it's in a textbook assignment or on a quiz or test. But we're going to prove the alternate interior angles converse. So copy this down in your notebook. We are given that angle 1 and angle 2 are congruent. Now notice the proof statement is to prove that the lines are parallel. Right now, we cannot use the converse of the alternate interior angle theorem because we didn't prove it. We didn't prove the converse is true. But remember, with a postulates that we accept as true without proof, so we could do the same for its converse, okay? So there's no proof for the converse of the corresponding angle postulate. So we can use that in a proof, which is what we're going to have to do here. Okay, so here, I'm going to erase this. I don't need this on here. Okay, so angle 1 and angle 2 are congruent. What else do we know? Now, in order to use the converse that we know, which is the corresponding angle converse, we're going to have to show that 1 and 3 are congruent in order to show that the lines are parallel. So we are given that 1 and 2 are congruent, but we also know that angle 2 is congruent to angle 3, right? And that would be by the vertical angle congruence theorem. And again, remember, if we're thinking about that step right before M parallel to N, we're going to have to show angle 1 is congruent to angle 3. Is there a way that we can do that? Well, we know angle 1 is congruent to angle 2, and 2 is congruent to 3. So the transitive property, which we blanket as that substitution property, is that angle 1 is congruent to angle 3. And therefore, our last line, M is parallel to N, and this is by the corresponding angle converse. Okay? It's very important that you write that word converse because it's not just the postulate. The postulate tells us the angle angles are congruent. The converse tells us that the lines are parallel. So here I just have an example for you, or actually two examples, to see how you know when to use the postulates or theorems, or how you know when to use the converses. So let's say that we're given 1 and angle 2 are supplementary. Okay, if we look at angle 1 and angle 2, we can see that those are consecutive interior angles. We are given that they're supplementary. So think about that conditional. If two lines are cut by a transversal so that consecutive interior angles are supplementary, then ... Well, then we know that A is parallel to B. That is the converse. It would be the converse of the consecutive interior angle theorem, not just the theorem. The theorem would be the reverse of that, okay? Now, if we look at another example where we're given that A is parallel to B, and we want to prove that angle 1 is congruent to angle 2, okay? So here we're given these are parallel, all right? Well, if two parallel lines are cut by a transversal, then what do we know? We then know that angle 1 is congruent to angle 2. That is our original theorem that we learned back in section 3.2. Therefore, your final proof statement would have the reason of the alternate interior angle theorem, not the converse. Okay? Converse would be if we wanted to prove the lines parallel. So I hope you could see that difference. We will be doing proofs, and in the proofs of these, you will have to know whether to use the theorem or postulate versus its converse.